Well, hello everybody. Welcome back. This week we're going to be covering bonds in this video. So there's really just two types of bonds we'll be covering in this class. We have a zero coupon bond, and that's really just we have a face value. Let's say it's worth $1,000 or $2,000, and that means at the time it expires or the expiration date, we will get $2,000, and we will pay an upfront cost today to be able to get this money in the future. Now, this is also a really good way for, let's say, in test questions to figure out I, because let's say we're going to pay $100 today. Today we pay $100, and then in 5 years from now, or in next year, let's say, this is now 100 we pay, and then next year we will get $120. So we see that we'll get $20 in 1 year. So from that, we can notice that the interest rate would be 20% in this question. And from that, we could continue going forward on that. We could also use this for spot rates, just in case, let's say, we know that there's different interest rates for different years. So we have, let's say, this year, next year will be worth that much. And then the year after, in 2 years, it would be 130. It would only be worth $130. So we know the interest rate would be 1.3 to the 1/2 minus 1 for the effective interest rate for those 2 years. Now, we also have coupon bonds, which is another thing we'll go over in this class. And this is also good for the actuarial calculator that I hope everyone has. So we have coupon bonds. And that's when we get coupons along with the face value at the end. So the coupons are usually a price or a percentage of our face value. So let's say we have the $2,000 bond with a 10% coupon. That happens semi-annually. So that means that we have 10%. So we get $200 for semi-annual. Let's say it's a 10-year bond. So that means we're going to get 20 coupons of the 200. So that would be 20 A angle 20 at the I effective, that is, we'll have I is equal to 10%. So we'd have to convert it to the I effective for this, which is I prime, I'll put it as, and I prime is equal to 1.1 to the 1/2 minus 1, because we know we have a 10% effective interest rate. And then to get the price, we know it's this 200 A, so I'll get rid of that now, angle 20 at I prime. And I just put that 2 there just to show that it was a semi-annual bond. But now that we have the I prime, we know that from over here, so we don't have to add that in. But you could, it's a good habit, I guess you could say, just so you don't get lost, or when you're going back through your work, you can double check it easier. And then plus the face value of the $2,000 divided by 1.1 to the 10. And that's how we would get the price of the bond. Now, there's also some other bonds like Treasury and all those common ones. I know Treasury and the T-bills are tested on the FM exam, so I would get used to those, especially before you take exam FM. But usually we focus mostly on these two type of bonds. We definitely will use the zero coupon bond to show interest rate and the varying years, like we showed with the 120 for year 1 and then 130 for year 2. So you can see that we have different I effectives for different amount of years investing. That's just because we're just trying to show some of the variability and how for different years, the interest rate's not always going to be the same, just because we always know the market's changing and investment ways change from time to time. So we know that the price, we'll show that, is equal to the coupons. So we'll say coupons, A angle N at, we'll put I prime plus face value, face, times V to the N. And that will be N times M. So we'll put I to the M up here. So that will be our value for coupon bond. And if we know if there is no coupons, so if coupons equal 0, the price is just equal to the face value times V to the amount of time. So those are the formulas there. And the M is just to show the amount of months that we compound. So if we just have one, we just leave it as effective. And that will be just it. We usually will work with either semi-annual or annual coupons, just because those are, I think, the most common. And not all bonds need coupons. Everyone, I'm sure, is aware of bonds. Your local government uses them all the time. The government uses them all the time. So those are pretty much default free, just because we know, or we hope, the government will be always around. There's almost zero chance of it not being here. So we always know that they'll be able to pay back, just because they literally print money. So we'll get the bond back at that time at the price they will say. So now we're going to go over to two examples. We'll start with a zero coupon bond. So zero coupon. And the face value is $1,000. And since it's zero coupon, we know that there are no coupons, so we don't have to take that into effect. And we're going to have I is equal to 10%. So, and it is 5 years long, 5-year bond. So now we have to calculate the present value. So present value at this at time 0 is equal to 1,000 divided by 1.1 to the 5th, which is equal to 620.92. And like I was saying earlier in section, make sure you at least have 2 decimal places, just because we're working in money and we're always working money. So don't round to the whole dollar, just because when we're working in millions. So if we had, let's say we had 100,000 of these, if we round to 621, and we have 1,000 of these, we would add 3 zeros. But in reality, we're only worth, so we actually said we had $80 more than what we actually did have. So when we go back and looking at where all that extra money came from, we could see that there could be a big difference, just because you expected to have $80 more, and when we have a bigger magnitude, the difference will be even larger. So make sure you're rounding to at least the pennies. More decimal places is fine, more could be better. You're not going to be penalized for adding more for sure. And now let's go break it off and see what happens if I is equal to 6% at year 3. So at year 3, that means we know we only have 2 years left till the bond expires and we get the face value back. So we know it's 1,000 divided by 1.06 squared. And for those who are a little bit confused with that, we have 5 years total minus the 3 years we've spent. So we have 2 years left. So that's why we do that. And it is equal to $889.99. And now let's see what happened if I is equal to 12%. Then it would be 1,000 divided by 1.12 squared. And that is equal to 797.19. As we see, this is less, just because of interest rate has risen. So let's see if I is equal to 10%, or the original amount. We'd have the 1,000 divided by 1.1 squared, which is equal to 826.45. Now, if you think about this, you're saying, why might be a little bit confused why the 12%, the 10%, and the 6%, you're saying 6% is lower. So why, if we sold the bond today, we could make more money? But if you're trying to sell the bond, and right now everyone can only get a 6% investment and yours worth 10%, then you will make a lot more money selling your bond, just because your bond is priced at the 10%. So you have it valued at this. Well, right now you can only buy a bond in $1,000, so that's worth that. So you have a larger return on your money than what people can buy in the market right now. But if the interest rate goes up and it's up to 12%, then you can buy it for even less. So since you can buy it for even less, your bond is now overpriced. So you'd actually start losing money if you sold it into the market today, because you could only get the $797 based on, just because of the new interest rate, even though you're at $10. So you would lose money at that time if you had to sell it early. But you would still get the $1,000 if you waited till expiration, those extra 2 years. So I'd keep that in mind, the fluctuations in I, because I know for some people that could be confusing, a little bit counterintuitive, how you'd actually make more money if the interest rate fell, but if it rose, you'd lose money. So that's just based on when you sell it, of course. So now let's go to a coupon bond example. So we have another $1,000 5-year, $1,000 face value, 5-year with a 5% coupon on annually. So we know the formula to find the price for this would be the 5% of $1,000, which is 50, A angle 5, and I is still 10%. So 10%, plus we still have to discount the $1,000, so 1,000 divided by 1.1 to the 5th. In here we get it is equal to 810.46. Now, if you remember from the previous example, the price was about 620. So we see that adding these coupons on added a significantly more value of it. And that's just because, as we know, for the time value of money, that we're getting money early on. So that extra money we have to pay for, especially since we're getting it earlier too, and along later. So we're getting it from time to time and time again. So we get it at those annual increments for 5 years, and also that extra $1,000. So we got to make sure we include those bonds, just because those coupons, I apologize, just because they do add a significant difference to the prices you guys can see. Now we're going to go do the same example and show what would change at year 3 if I is equal to 6%. So we know that now we have our 50 A angle 2 at 6% plus the 1,000 V squared. We get that is equal to $981.67. So that is the price for the coupon dot at year 2, with 2 years left till expiration, since we're at year 3 right now. And then let's go see what happens if it was 12% again, that same time period. So we have the 50 angle 2 at 12% plus 1,000 E squared, and we have it as $881.70. And then if I remains 10%, we have it is equal to 50 angle 2 at 12% plus 1,000 V squared. That is equal to 913.22. So yet again, we see that when if I decreases, the price for it the price for the bond shoots up. So if we sold it, we could make money compared to our 913.22 that we have currently. But if I dropped, the bond would be worth less money, as we would lose it again. So this is a good way to double check it when you're doing the work, maybe on homework or the quizzes, maybe the final and midterm. You could just double check it at the normal rate that we had originally. And we could see that, okay, interest rate rose, we know the value should decrease. So you just compare them, and if you see it is the other way around, you know you made a mistake somewhere. So that's another nice way to double check it, just to see if your work is right. And we also see here how in this case scenario, the same principle applied with when I changes the value of the bonds, changes it with 2. So that's also a good thing. Maybe if you get like a definition question and you have to explain it, you could say that just because the value of the money you're getting has a difference, because you're paying at the 10%. So if it's currently at 6%, you're making extra percentage compared to everybody else in the market that wants to buy it right now. So when you're selling it, you get that extra money compared for everyone else, and vice versa when it is 12%. So I hope to see you guys in office hours on Monday or in section Wednesday. That's all for today's video. Just wanted to go a brief overview for those who can't make it to section, and I hope you guys have a great weekend and your quiz are going well.